You know this.
Yeah, how do you already know this one? He's smart. He's smart.
All right.
He's a hacker.
So we haven't talked about logs yet. Everybody get your calculator in front of you. Does anybody see the log button? There's a log button on your calculator. We're going to be learning how to use that today. Right? So there's a rule that we use to convert between an exponential and a log. It's really straightforward. It's like a little loop. We call it the loop trick. And it will work for going in either direction. So we're going to talk about how to convert between these two forms. We're going to talk about how to evaluate, and then we're going to learn how to solve. So all those different kinds of things that are closely related, we're going to do those steps. So here's your rule that you guys do need to know. Oops. I don't want to move the page. All right, so go ahead and highlight the little statement that's at the top here. For any positive base b, where b is not equal to 1, so your base is not going to be 1, it's going to be 2 or higher. If you have this kind of equation, your exponential, this is the exponential one, right? If you have an exponential, the base raised to the x power equals y, you can convert it to this. This is the log form. Logarithm is a weird word and it's hard to spell, so we usually just abbreviate it to log. So we're going to be using that instead of the full logarithm as we're working through this. Alright, so the way that we do this, notice that the b here, that's what? What does b represent? The base. See how it's like a little number right here, a little subscript for the log? The log also has a base, and that's where it goes. So the base for the exponential is also the base for the log. And then the y was the answer here. It's going to be the input for a log, and then the x is the exponent here, but it's the answer here. So I'm going to show you a little trick. I want you to I'm going to write it bigger so that it makes more sense. Hold on. I'm going to make it bigger so that I don't take up too much space. If you guys write like this, if you draw a little loop, starting at the b, going towards the equal sign and back to x, that shows you the order of how it should be written in the log. So here I go from b to y to x. That's the order that it will appear in for the log. Product of like. So watch. When you have the exponential, you're going to start at the base and loop towards the equal sign and end at the exponent. So the first thing I have is b. So it's going to be log base b. The next thing I hit is y. So of y equals, what's the last thing I hit? X. That's the loop trick. Yeah, and it won't work in either direction. You can do the loop from the exponential to get to the log, or you can even go the other way. You can do the log around like this. If you have the log first and you're going back to the exponential, it would be base b raised to the x equals y. So the loop works for either of them. And we'll practice that for these examples so it makes more sense. But that loop trick is what you use to convert between the two different forms. Okay? So for example, this one, I have the exponential first. I'm going to convert them into log. So if you want to physically draw the little loop, you can. Right? So I have exponential first. So I'm going to convert to log. So I'm going to write log. What would the base be? 5. So it's a little 5. And then what's the input? 125. And then what's the answer on the other side? 3. So that's how you convert it. Log base 5 of 125 is equal to 3. Okay? Let's do the loop again. Start at the base, go around. You have to go towards the equal sign when you draw the loop. Right? What would this look like? Log base 6 up to 16 equals 3. See how I did that? Right? This one's set up different. See how they swapped the order of the expressions here? You always start at the base and go towards the equal sign. So the base is 3. I'm going to go towards the equal sign, so I'm kind of reversing the loop here just because of how they've written the equation. You always start at the base and go towards the equal sign. So how would I write this one? Log base 3 of yes. So it depends on how they write the equation for you. They could have the exponent stuff on the right or the left, but you always start at the base and go towards the equal sign when you draw the loop. So it could be clockwise or counterclockwise, depending on how they write the equation. All right. What about this one? Nope, the base is 4. So log base 4 of 1/2 equals x plus 2. All right, we're only converting. Right, we'll learn how to solve that a little bit later. Right now, we're just converting. Say again? The bases should be the same. Yeah. So if this is the base for the exponential, it should be the base for the log. Yeah, it's what's underneath the exponent. All right, this one they wrote it in the reverse order again, so it's going to go this way. The base is 2, log base 2 of 64 equals x. And this one, we're going to write this one a little bit different. That's where this statement here that I bolded is going to come into play. Log base 10, you don't write the 10, you just write the log. You know, like when you guys multiply times 1, you don't usually write 1, like if it was 1x, you just write x instead of 1x. The definition of log is base 10. When mathematicians or whoever invented logs, it was in terms of base 10, so they didn't bother writing base 10, they just wrote log. So that's the definition of a log, is that it started as a base 10. So whenever you guys have log base 10, like we have here, instead of writing log base 10, you're just going to write log, just log, of 100 equals x plus 3. So whenever you guys have a base of 10, don't actually write the 10, just write log. And that's what the button in your calculator is for. The button on your calculator will only work for a base 10. That's why it just says log instead of log base something. So when we're evaluating, which we're going to have to learn in a little bit, if you guys have a log with some other base, you have to do something different. But the button in your calculator is made for base 10. Alright, is everybody okay with the conversion from exponential to log? Great, now we're going to go in the other direction. We're going to start with the log and go to exponential. Right, it's the same rule. You get to do the same loop trick. You start at the base, you go towards the equal sign, like this, and then you end right there. Right, so if I was writing this as an exponential, what would the base be? 8. Right, the bases are going to be the same, so it's 8 to the what power? 3 equals, oops, I'm writing it wrong, 12, right? For these ones, you guys can actually verify in your calculator. Right, is 8 to the 3rd power 512? You can verify in your calculator. Right, so if you mess up and you accidentally say like 3 to the 8th power is 512 or something, you can always double check in your calculator to see if you did right for these ones in particular. What about this? 9 to the 2nd equals 81. You guys should know that one, right? 9 squared is 81. That makes sense. All right, what about this one? It's 10. See how it doesn't have anything written? When it's not a written base, you guys have to remember it's a 10. And this one we're going counterclockwise for the loop. So it's 10, yeah, 10 squared equals 100. They could switch the order of the loop for either of these. Great. What about this one? 4. So 4 to the negative 3. Yep. 4 to the negative 3 equals 1 over 64. Yep, this is another base 10. You go towards the equal sign and then loop back around. Yep, 10 to the 3 equals x. Squared. Yep. Okay, so does everybody see how we do those conversions? We're going to need to know how to do that for solving at the end of the lesson. We're going to come back around to this. That's going to help us solve. Like these two equations where you have x's in them, you have to do the conversion first, and then you would do the algebraic steps to finish solving it. So you guys need to know how to convert to begin with. Is everybody okay with that? Hunter, say it with us, Ben. Everybody's okay with that, the conversion? All right. Now we're going to figure out how to evaluate, how you guys actually figure out what a log is by using your calculator. So there are 3 different types of logs. We're going to talk about the natural log on the next page. We're just going to talk about 2 of them for now, and then the 3rd one will be later. Base 10, that's what your calculator is made for. So if you see in any of these examples, you don't see the base written, you just see log of something, that's what you can use your calculator for. So if it's base 10, just plug it straight into your calculator. If it's not base 10, so like this one, see how it's log base 5? We have to do something different. It's called change of base. This right here, this method called conversion, only sometimes works, so I'm not really going to dwell on that one. Change of base is always going to work, so I'm going to focus more on that method. So change of base is a property that we know about a log, and it's written right here. What's the change of base? So if you guys have something that is not in base 10, you can still use your calculator to find it. You just have to turn it into a fraction. So if you guys have log base b of a, you're going to do log of a, so it turns it into base 10. You're going to do log base 10 of a divided by log base 10 of b. So see how I have the base and then the number that's plugged in? What I like to say is, see how a is bigger font? A is a bigger font and the b is smaller because it's a subscript. We always do the bigger font and the numerator and the smaller font in the bottom. Or you can think base bottom, whatever the base is, that should be in the bottom of the fraction. And you put that in your calculator and that's how you get the answer. So if it's not base 10, you have to use that little division trick to figure out the answer in your calculator. Okay? So for example, this one right here. Can I just push the log button of 25 and get the answer? No, because this is not base 10. So I'm going to have to rewrite this. You're going to do the log base 10 of 25 divided by log base 10 of 5. So in your calculator, everybody push the log button. It's going to open a parentheses. You're going to type in 25 and then close the parentheses. It is incredibly important that you guys remember to close the parentheses before you hit the divide. So log 25 close parentheses divided by log of 5 close parentheses again. Push enter. You should get 2. So they ask you to evaluate. They want to know what is this? What's the value of this? Right? This is like a symbolic representation of a number. They want to know what that actually is. Evaluate. You would use your calculator. It's 2. Alright, what about this one? Is this base 10 or not? This is base 10. That's what your calculator's for. So you can just type log 1. Log 1. That's what your calculator is for. You don't have to close parentheses unless it's a division. Okay? So it's a 0. If you guys don't see a base, that's what your calculator is for. Just type it in, push enter, good to go. So you should get a 0. Can I do that for this one? Is this base 10? Nope. I have to use the division trick. So it's log 16 divided by log 5. 1.7. Yep, 1.72. You can get this. 1.72. Right, well, what do I do for this one? Just stick it in your calculator, right? This is base 10. So you just write, or type the log button, then 10, push enter, 1, you get a 1. Ready? Is this base 10? No. This one you're going to have to use the division trick. So it's log of what? 8 divided by log of, okay, when you divide something by itself, what do you get? A 1. You don't even have to type that in the calculator if you don't want to. If you divide something by itself, it's automatically a 1. Right? What about this one? Yep. Log of 3 divided by log of 7. 0.56. Alright, you guys are getting it? Can you finish the rest of them on your own? Go ahead and finish the rest of those examples. Then we'll come back around and see if you guys got the right answer. Get it simple.
see a base written down. Like here's it's unwritten, it's based on you just automatically plug in your calculator.
Yeah.
Just do the log, you know, and it's the log button, and whatever that is. If you don't have a base like here, what you have to do is do this. Whatever the base is, then you're going to do the log of that in the bottom, which is the log of that in the top. So it's like for this one, like technically, right? And for that one, you have to write it as log 25 divided by 25.
I know.
Just waiting for you have to close parentheses, you have to do that and divided by a log of 5. That's what you do when it doesn't.
All right, somebody willing to volunteer. What did you get for 19? Melissa?
I got 0.
Yep. Everybody good with that? Okay, next one. Number 20. Okay. 3. Everybody get that? Okay, 21. 3 again. 22. What do you guys get for 22? -1, okay. 23.
-4.
Alright. Last one. Yep. Everybody get those?
Yeah.
Alright, so that's how you guys would evaluate. So the 2 skills on this page, converting and evaluating, those are the 2 things we're going to put together to solve. So to solve something, those are the only 2 things you guys need to know how to do: convert and then evaluate a log. Before we get to the solving, I want to talk about a different kind of log. Underneath the log button, you guys should see LN. You guys see the LN button?
Yeah.
That is called a natural log. So that's another thing that we're going to be using when we're talking about logarithms. So we already know one mathematical symbol that represents a number, pi. Right? We use pi all the time, knowing that it represents a number. It represents 3.1415, blah, 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 right? We're going to introduce a new one called E. We also have I. I represents the square root of -1, right? We have a lot of symbols that are letters or Greek symbols that represent numbers. We're going to be bringing in a new one called E. E represents 2.72 rounded. That's how we usually approximate E. And so we're going to be using that when we're talking about the natural log. Everybody should also have the E button on their calculator, but I think it's a second something. For most calculators, it's second divide. That's how you get E. We learned that for the PERT formula, right? So E is most commonly associated with the natural log, even though we do use it with the PERT formula. So this little chart right here, this table explains the difference when you're converting between the exponential and the logarithm. So using an E, this is what the exponential looks like. The base is E. When you guys are talking about an exponential using E, the base is E. We call that the natural base. When you convert it to a log, you're going to start by writing it this way, but this is not how you would leave it. We don't write log base E. Log base E is translated into ln. Ln represents natural log, which you would think would be an L, but it's ln, right? Because natural log has the n first and the L second, but for some reason they have the L first and the n second. I don't know. But the natural log is abbreviated ln. So you guys don't ever write log base E. If you guys write that at first, that's okay, but you have to change it to ln afterwards. So whenever you guys have a base that's E, you turn it into natural log of x, and you would just use that button on your calculator. So well, it's the same idea. We're just going to do conversions, and then you use your calculator. It's the exact same idea. We're just using E as our base instead of like 2 or 3 or something. Right? So this table right here, we're going to practice converting using the E. So if this is the log form, and I want to convert it to the exponential, we still use the loop. The base is here. We go towards the equal sign and loop back around. Now I don't have the base written, but what do I know the base is for a natural log? E. When you guys see ln, the base is E. So when I turn it into exponential, the base is E. What would be the next thing I would write as the exponent? X equals y. So it works the same way. The loop trick still works the same. It's just that the base isn't written there. You have to remember that for an ln, the base is E. It's just like for this, when we had log of 3 equals x. You guys remembered that the base was 10 even though it wasn't written there. For an ln, you have to remember that the base is e even though it's not written there. Alright, what if I go the other way? What if I have e, I know it's a little bit small, but that's a v and that's a u. How would I write that? What's the base? It's, here, let's do this. We're gonna write log base e for a second, so it makes more sense. Log base e of what? V equals u. So you can write this at first, but remember log base e is not the appropriate way of writing this. So you can write this first, but then you convert it. So what's log base e written appropriately? Ln. So it'd be ln of v equals u. Feel free to write it like this first, that's fine. Just make sure you turn it into the ln at the end. Okay. This one. Start where the base should be, loop towards the equal sign and then back around. So what's the base for ln? E. So that's e to the 10th power equals x plus 3. Same loop rule. Just a different base that's going on. Alright, this one, start where the base should be, loop around the equal sign, and then come back. So what's the base for a natural log? E to the, yep, you have a decimal in the exponent position, equals 5. You can even verify that one if you wanted to. You could do e raised to that power and see if it really equals 5. Just make sure you wrote it correctly, which it does equal 5. Alright, now we're going the other direction. We have, my board just moved, hold on, let me put it back. Right, sorry. So drawing the loop, I start at the base and I loop back around. So it's what? Log base what? E of 1 equals 0, but you don't want to leave log base e, so that's not how you would write it. ln of 1 equals 0. You just change the log base e into an ln. And I did the little loopy L to tell the difference between the L and the 1. Okay? What about here? Oops, sorry about that. So what's the base? E to the first power E. That should make sense, right? E to the first power definitely equals E because anything to the first power is itself. Alright, what about the last one? Log base E of what? Yep, but then you have to change the of 20 equals. Yep. You can just watch the last little bit of the video. Alright? Does that make sense? What if it's what? Say it one more time. What situation are we talking about? Oh, it's squiggly line means approximately. So like when you like on the homework, it just means that it's approximately that, so it rounds to that. So you just pretend it's like you treat it as normal. Yeah. All right. So everybody okay with converting with the e's? It works the same way. You just imagine that the base is e in that situation. Okay. All right. Now, the last thing we're going to talk about is how to solve. So solving puts those two things that we've talked about so far together: converting and then evaluating using your calculator. So what you're going to have to do, I have the step written right here in one line. What you're going to do to solve is you need to convert to the other form. In this first example here, see how the x is in the exponent position? I can't solve with it up there. Right? It's kind of stuck there. I can't do anything with it in the exponential form. So whenever you guys are solving, you need to put it in the opposite form, the inverse. An exponential and a log are inverses of each other, which we're going to explore more next time. But they're inverses, so you're going to convert to the opposite form. So if it's exponential, turn it into a log. If it's a log, turn it into exponential. Then you're going to solve by evaluating your calculator and using basic algebra. So sometimes you're going to be using change of base. So if you're trying to evaluate a log, you may have to use the change of base like we just practiced to find the value, but then you would just solve it using regular algebra. So for this one, what form am I in to begin with? I'm an exponential form. So in order to solve, what do I have to do first? Turn it into a log. Okay, so we're going to use a conversion. We're going to start at the base, loop around the equal sign, and then go back around. So if I turn it into a log, what would it look like? Log base 2 of 32. Okay, so I've rewritten the equation. Now see how the x is free to move around now? Now that they're on the same line like this, I'm able to move the x around and actually solve for it. So what I'm going to have to do next is the log base 2 of 32, that represents a number, right? Okay, we need to figure out what that number is. Right, so that's when we use change of base, like we practiced on the previous page. We're going to do log of 32 divided by log 2. 5, okay? So then I can rewrite this equation as 5 equals 4x minus 5. See how it became a lot more simple all of a sudden? So now how did I finish solving that? Add 5 divided by 4. 10 divided by 4 is 2.5. So your x is 2.5. That's what I solved. Okay? Next one over. Slight difference to this one. Has an extra -10 there. So I think you'd have to do first. Add it over. I call this the housekeeping step. You need to make sure it's all neat and tidy before you can actually do the solving process. So if there's anything that you need to add or subtract over, you're going to have to do that first. So this would become 10 to the x equals 7,210. Okay, do that first. Now that it's all neat and tidy, what do? You have to turn it into the log form. So again, do your loop, right? It would turn into log base 10, which you don't have to write, of 7,210 equals x. Right? Doesn't log base 10, Michaela, can you get the door, please? Doesn't log base 10 of 7,210 represent something? How do I figure out what that is? Yeah, just type it into your calculator. Go ahead, what is it? What is that number? Anybody?
3.8.
I'm going to go ahead and round it. So you don't have to do anything extra beyond that. You just have to evaluate the log, and there's nothing else to do, so that's the answer. Right? Alright, what about the next one? It's currently an exponential form. Turn it to the log. Log base 3 of 81. Yep. And doesn't this represent a number of some sort? Okay. Log of 81 divided by log of 3. Remember your change of base? It's 4. Okay, so 4. X equals 2. See that? Okay, we're going to do the same thing, but now we're going to switch into when the base is e. We're going to see if we can do the same thing with the natural log. So it's the same process. If it's an exponential, you still need to turn it into a log, but this one's going to be the ln, the natural log. So again, I'm going to have to convert. So how would I write that if I do this version? It's log base here, ln. Yep. So it's just the natural log of 981 equals x. So you just have to evaluate that. And your calculator, you just push ln and then that number. 8. X equals 8. Good job. That's listening. Alright, what about the next one? ln of 27. Okay. Well, you have to find ln of 21 first.
21.
Sorry, 27. Find the natural log of 27.
3.3.
Okay. And then add the 1 to that. So you can't add the 1 until you know what you're adding 1 and 2. So that's why you have to find the natural log or whatever first. Alright, now we're switching into the other ones. We're starting with the log and we need to go the other direction. So if we start with a log, what do I need to turn it into?
Exponential.
The exponential. So we're going to do the same thing that we did before. Okay, so if I start with a log, I need to convert. So how would I do that? Start with the base, towards the equal sign, and then back around. So how would I write it?
So,
4
to
to the 5th.
equal 2x minus 8.
There you go. Can I find what 4 to the 5th power is?
Yes.
Yeah. You can just use your calculator to do that. What's 4 to the 5th power?
1,020.
Yep. So you add the 8, divide by 2.
I got
the 8.
516.
516. Alright. Alright, I'm going to let you guys do the next two on your own, see if we can figure those out. And then we have to pause and talk about number 9 together, because it's a little bit different. So I want you guys to try 7 and 8 by yourselves, see if we can figure it out.
Like for this one, I feel like it's more eggs, and then for the first, which is negative 2, but I don't know. I'm just
You can just type e to the power. Try rewriting it after you added the tables. Your conversion if you want to. Or sorry, the exponential. You should have the exponential. Just rewrite it. Right, log of 4x equals 3. That is actually 3.
Oh, you added this over?
Oh yeah, then you have to probably. So what's the base?
Or 3.
What's the base? What's the base? To the
3 equals 4.
If you guys don't remember, E is second divide. You need to evaluate E in the calculator. It's a number, so you can just stick it in.
I guess now. I got 250.
Alright, pause for the last one, just do 7 and 8. Alright, who can walk me through number 7? Who can walk me through number 7? At least one part of it if you couldn't finish it. Anybody? Go ahead.
Okay, so I'm going to do the exponential. So we have the e, and the base would be the 4.
The base is E.
Oh,
The base is E.
Yeah, and then obviously 4 exponent, and then equals x minus 2.
Yeah, We've already done that, guys. That part you should definitely know how to do, because we just practiced that above. Right? If you have an ln, that's how you convert it.
And then we just put the calculator the second divide 4
Mhm.
and get 54.5.
50.6.
0.6.
Yep, 54.6.
Then equals x minus 2 x minus 2.
Yep. 56.6. Alright, you can find e to the power in the calculator. So remember, e is just a number. It's 2.72. It represents a number. So to find this, you don't have to leave it as e to the 4. You can actually find what the number is by doing e caret 4 on your calculator. Push enter, and it'll give you 54.6. Remember, e for most calculators, second divide is how you get the e on the screen, and then you do exponent of 4, enter. Okay, so you don't leave it as e. You actually evaluate what the number is when it's over here. So you get 56.6. Everybody okay with that one? Right? And what do you have to do over here with this one? What was that? Okay, housekeeping, you have to make sure that whether it's an exponential or a log, you need to make sure that that piece, the exponential or the log, is by itself. So if log of 4x equals 3,
And then
move it over.
you just do the loop thing, and then you just get
Okay, so pause for a second. What's the base? It's a 10. Remember, when it's not written and it's a log, it's base 10. So it's base 10.
to the third.
Yep.
And then equals 4x.
Yeah. So 10 to the third power is 1,000, right? Then you divide it by 4, you get 250. Right? When the base is not there and it's an ln, the base is e. When the base is not there and it's a regular log, it's base 10. You guys do have to remember that. Okay? Now this one's a little bit different, but it's actually simpler, right? So we're not going to be doing a conversion here. The way that we're going to approach this is different. So we don't have a log equals a number, we have a log equals a log. So what do you guys notice about the two logs here? They have the same base. So if you guys know that the log base 2 of something equals the log base 2 of something else, what do you know about those two things? They're equal. Shouldn't they be the same? If you're taking the log of this exact same base of two things and they're both the same solution, shouldn't the things that are inside the parentheses be the same? So that's what you do to solve. You say that x plus 2 should be equal to 3x minus 16. So if you have two logs of the same base on either side, you get rid of the logs and just work with what's inside the parentheses. Alright, so how would I finish solving that? You usually want to keep the x positive, so you pull it over.
Yours is minus 16. Yours says it's plus.
It says plus. That's fine. Alright, and then I subtract it over, so that would be in, what is it? 2 minus negative 14? Okay? And then 2 divided should be negative. What? I subtract it this way and then subtract it this way.
Yeah, and then
Negative 7. Okay. I think there was a reason why I changed that to a negative in the notes and then forgot to print it out for you guys, maybe. I don't think you're actually allowed to have negative numbers inside of the log. That might have been why I changed it here and then forgot to change it there. So, I'm fairly certain, I'll have to check again, but I'm fairly certain that you can't have a negative number inside of the log, so that would actually create an error if you try to check your answer. So that's probably why I changed it to a minus, but you're not going to see much of that type of solving, so that's just for you to know. Alright, so does anybody have any questions about anything we talked about? That's not what I talked about. There was pluses. Alright, nobody has any other questions? Alright, so one more time, I want to make sure you guys are aware. Put this on Blackboard, so you guys have it to check if you forget. The only assignments that are left for third quarter are the homework and quiz for this lesson and next lesson. Okay, so the first 2 homeworks and quizzes of this unit are going on this quarter. So if you missed a class, you need to catch up really quick because the quarter ends next week. So if you guys missed last class, it was a little bit of a long lesson, right? So the video is a little bit long, but you can get with a friend or with me after school if you need to talk it through. But watch the video, fill out the notes, catch up so that you can make up all the work that you need to do before the quarter ends. Okay? And then I don't remember if I talked about the bump up quiz for you guys. So by April, by April 11th, once all of the grades are in that I'm going to put in, if you're within a percentage point of rounding up to the next letter grade, you can take that quiz on April 12th during lunch. And if you get above a 75, then I will bump you up. Change them. No, it needs to be within 1% of rounding up. 1%. Not above that. No, that's crazy. Crazy. Crazy.